Welcome all of you in this lecture. My name is Dr. Vishal Patil. I am working as an associate professor in Department of Mechanical Engineering, Sharan Institute of Technology, College of Engineering, Hyderabad. The name of the subject is thermodynamics. In today's session, we will study the fundamental concepts related with the thermodynamics and energy, thermodynamic system, thermodynamic properties, and thermodynamic equilibrium. The main objective of this session is to learn the basic fundamental things related with the thermodynamics. The name thermodynamics deals with the Greek word therm. Therm means heat, and dynamics it is related with the power. Means the main basic theme of this subject is to convert heat into work. The content for this presentation is: first one is thermodynamics and energy, applications of thermodynamics, thermodynamic system, state of system, properties of system, and thermodynamic equilibrium. The next slide it is related with the thermodynamics and energy. The thermodynamics can be defined as the science of energy. The energy can be defined as capacity to do work. According to law of energy conservation, energy neither be created nor be destroyed. It can be converted into one form to another form. The total energy in the universe is kept constant. As per the classification of energy, energy is mainly classified into two types: stored energy and transit energy. The stored energy is further classified into three types: potential energy, kinetic energy, and internal energy. According to first law of thermodynamics, it is simple an expression of non-conservation of energy principle, and it is related with the energy is a thermodynamic property. The second law of thermodynamics assess the energy has quality as well as quantity. In actual process occur in the direction decreasing the quality of energy. For example, a cup of hot coffee left on the table eventually cools, but the cup of cool coffee in the same room never gets hot by itself. The higher temperature energy of coffee is degraded and transferred to the surrounding. This macroscopic approach to the study of thermodynamics that does not require knowledge of behavior of individual particles is called classical thermodynamics. It provides direct and easy way to solution of engineering problems. A more elaborated approach based on the average behavior of large group of individual particles is called as statistical thermodynamics. The next slide it is related with the applications of thermodynamics. The thermodynamic subject is widely used in nearly all the branches of engineering. It is mostly used in mechanical, automobile, production, and aerospace engineering. I have shortlisted some areas of applications of thermodynamics. First one is air conditioning system. In air conditioning system, we are controlling and maintaining conditions of air with respect to human comfort. And human comfort it is related with the psychological and physical condition of human being. For cooling purpose, we are using the basic concepts of thermodynamics. The second application is it is related with the aerospace engineering. Aerospace engineering it is a now prestigious area, or it is most important scientific area. The aerospace consists of different domestic and commercial flights as well as the aircrafts and launching of satellites. The thermodynamic concepts are used in many ways in aerospace engineering. Next one is food processing units. The thermodynamic concepts are widely used in food processing units for the maintaining the temperatures and other basic properties. Next one is Automobile industry. The basic concepts of thermodynamics, just like combustion, then aerodynamic, shape, and other things related with the thermodynamics. The next application, it is related with the refrigerator. In refrigerator, we are maintaining the temperature of food for the longer time. Means we are maintaining the temperature of refrigerator at 3.5 degrees Celsius, and we are maintaining the temperature of freezer is minus 18 degrees Celsius. Next application is wind energy. This is the application which converts the renewable type of energy, means wind energy, into power, and this mechanical power is then converted into electrical energy with help of generator. Next one is pipe industry or heat transfer industry or boiler industry. The basic thermodynamic concepts are widely used in this industry, just like two-phase flow boilers and other things. Next application area is human health related sector. The thermodynamic basic concepts are normally used for the developing the applications related with the human health and human comfort. The next point, it is related with the thermodynamic system. The thermodynamic system is mainly divided into three types. The thermodynamic system means system is nothing but it is a definite quantity of matter or substance, and this boundary system boundary, it is may be real or imaginary. The thermodynamic system is mainly divided into three types. First one is closed system or control mass system. Second one is open system or control volume system, and third one is isolated system. Means the examples of these systems are, for first one, closed system. The example of closed system is the famous piston cylinder example. Second, open system. The example of open system is nothing but open cycle gas turbine or air compressor. Then isolated system. The example of isolated system is nothing but thermos. In thermos, we can store the temperature of hot fluid. The thermodynamic system, or it is also known as a system, may be defined as the definite area or space where the thermodynamic process is taking place. It is a region where our attention is focused for the study of thermodynamic process. A little observation will show that the thermodynamic system has its boundaries, and anything out of this boundary is called as surrounding. The surroundings are maybe real or imaginary. The boundaries may be fixed like the tank enclosing the certain mass of compressed air, or moving like the boundaries of certain volume of liquid in the pipeline. The first figure, it is related with the closed system. In this system of fixed mass and identify, those boundaries are determined by the space of matter occupied in it. A closed system, as shown in figure, the gas in the cylinder is considered as a system. If heat is supplied to the cylinder from the external source, the temperature of gas will increases and piston will rise. As the piston rises, the boundary of the system moves. The heat and work energy crosses the boundary of the system during this process. But there is no addition or loss of original mass of the working substance. It is thus obvious that the mass of the working substance which is fixed during this process. In a closed system does not permit the mass transfer across the boundary, but permits the transfer of energy in the form of heat or work. The second figure, it is related with the open system. In this system, the mass of working substance crosses the boundary of system. The heat and work may be crosses the boundary. As as shown in the figure, the air compressor, it is an example of open system. The working substance crosses the boundary of system as lower pressure air enters in the compressor and leaves as a high pressure air. The work crosses the boundary of the system through the driving shaft and heat is transmitted across the boundary from the cylinder wall. Thus, the open system permits both mass and energy in terms of heat and work transfer across the boundaries, and the mass within the system may not be constant. Third important system is isolated system, a system which is completely uninfluenced by the surrounding is called as isolated system. It is a system of fixed mass and no heat and work crosses the boundary. An isolated system does not have transfer of either mass or energy with the surrounding. The state of system. The system is nothing but which having the definite quantity of matter or substance. The state means it is a fixed value of properties. The state of system in a thermodynamics equilibrium as shown in this figure. The state of system is a condition of system at any particular moment which can be identified by the statement of its properties such as pressure, volume, temperature. The number of properties which are required to describe the system depends upon the nature of system. Consider a system enclosed in a cylinder and piston arrangement as shown in figure. The system is initially equilibrium when the piston is at position 1. Represented the properties of P1, V1, T1 means pressure at point number 1, volume at point number 1 and temperature at point number 1. When the system expands, the piston moves towards right and occupies the final position at 2. At this system finally in the equilibrium state represented the properties of P2, V2 and T2. The initial and final states on the pressure volume diagrams are shown in this figure. The next point is properties of a system. In lots of application we are using different properties. The property should be sensible, observable and directly indirectly measurable. The properties for the system, it is related with the identify or describe a certain observable quantity such as volume, temperature, pressure and density. All the quantities which identify the state of the system is called as property. These thermodynamic properties are mainly classified into two types. First one is intensive property and second one is extensive property. First one, extensive property. A quantity of matter in a given system is divided into a number of parts. The property of the system whose value of entire system is equal to sum of their values for individual parts of system are called extensive property, just like total volume, total mass, total energy of the system. Second one is intensive property. It may be noticed that the temperature of system not equal to the sum of the temperature of individual parts. It is also true for the pressure and density for the system. Thus, the properties like temperature, pressure and density are called as intensive property. Means for the concluding for this property part, the intensive properties are depends upon the mass, just like total enthalpy, total entropy, etc. And intensive property does not depends upon the mass, just like pressure and temperature. Next, thermodynamics equilibrium. The equilibrium is a stable condition of the system. The thermodynamics equilibrium is mainly classified into three types. First one is mechanical equilibrium, second one is thermal equilibrium, and third one is chemical equilibrium. The mechanical equilibrium is a system is said to be mechanical when there is no unbalanced forces acting on any part of system or system as a whole. The pressure in the system is same at all points and does not change with time. The thermal equilibrium, the system is said to be thermal equilibrium when there is no thermal difference between the parts of the system or between the system and surroundings. In other words, the temperature of system does not change with the time and has the same values at all points of the system. Third, chemical equilibrium. A system is said to be chemical equilibrium when there is no chemical reaction within the system and the chemical composition is the same throughout the system, which does not change with the time. In today's session, we have studied the basic things related with the thermodynamics, energy, applications of thermodynamic system, state of system, properties of system, and thermodynamics equilibrium. These are the basic fundamental concepts of thermodynamics, which will help for the further concepts of basic laws of thermodynamics and other things. In next lecture, we will study the basic concepts related with the fundamental concepts of thermodynamics as well as laws of thermodynamics, mean first law, second law, and third law of thermodynamics. This video is specially prepared for the understanding the basic concepts of UG students. Thank you very much for patient listening. Thank you very much.